Hi, welcome to our channel, How to Calculate Variation in the Process. Today we will see how to calculate process variation. First we will understand what is meant by process variation. Process variation widely used in statistics. The variation will start from the individual point deviation from the mean. Example, like suppose you are measuring height of 10 people, the 10 readings will differ from the mean of the particular 10 readings. So the data will fall either side of the particular mean. So the variation indicates how the data is dispersed and how also called how data is spread out. So I mentioned one example like height. So the individual deviation from the mean can't explain the cumulative variation of the particular process, but we need a cumulative variation for the particular process. So that is called a process variation. So now we will see the types of measurement techniques for the process variation. First one is the range, second one standard deviation, and the third one is the interquartile range. So these are all the well-known method. Now we will see individually. The first one is the range. Range is the very simple method to calculate the process variation. It's calculated by the difference of the largest value and the smallest value. So I given one example. So now we will calculate the range. So range formula is largest value in dataset minus smallest value in the dataset. So in this data, the largest value is 100 and the smallest value is 70. So the range value is 30. The range indicates the 30 means here. So the entire data points in the range of 30 units. Now we will go to standard deviation. Standard deviation is the well-known method to calculate the process variation. So standard deviation will tell how individual data points are spread around the mean. It will give average value, average distance from the mean. Individual point, we can say how the individual points deviation from the mean. So now we will see with the examples. So I given one example like here 1357. We need to calculate the standard deviation. So the number of reading is n equal to 4. Now first we need to understand this data is a sample data or the population data. So this is a population data. So the population data, the standard deviation formula is square root of summation of x minus x bar whole square divided by n. So we have already the x indicates the individual data point and the x bar is the average and n equal to 4 we have. So x bar only we need to calculate. So x bar calculated by adding of all the value divided by the number of readings. So 1 plus 3 plus 5 plus 7 divided by 4. So the x bar value is 4. Now we can calculate the sigma value. So as per the formula, the square root and the individual value, like the first value is 1 minus x bar equal 4 whole square, plus second value is 3 minus x bar 4 whole square, plus 5 minus 4 as well as 7 minus 4 divided by the number of readings 4. So by calculating this we can able to find the standard deviation. The value is 2.236. Suppose the same readings indicate the sample data. So the formula is slightly differ and in the denominator it will come n minus 1. This formula everything similar, but the denominator n minus 1 for the sample data. So now we will calculate assume that it's a sample data and we are going to calculate the standard deviation. So the same formula, but the denominator n minus 1. So it will be root of 20 divided by 3 and 2.582. So this is the method to calculate the standard deviations. So here example, the standard deviation value in the sample, suppose 2.582. It's indicate how the individual point like 1, 3, 5, 7, its deviation from the mean. So suppose the process mean, suppose 4, here x double bar is 4. So how the individual data points in both side the average variation in both side, like 4 plus or minus 2.582. So the data will fall in that kind of a range. So this is a interpretation for the standard deviation. So now we will move to the interquartile range. So interquartile range also used widely, and it's indicate the middle half of your data. So middle half means the middle 50% of the data. Now we will see with the example. So I given some data points. This is 19 data points here. So we need to calculate the interquartile range. So first we need to arrange the data in ascending order, and if you arrange the ascending order, and we can able to calculate the IQR by using the Q3 minus Q1 formula. So how we will identify Q3 and Q1? So I given the 19 data. In that, the middle one 29 is the median. So we need to divide the data into two part, first half and second half. In first half, again we need to find the median of the first half, that is 20. I mentioned green color, that is your Q1. And in the second half, again the median value is 39, that is your Q3. So IQR, now we can able to calculate 39 minus 20. So the IQR value for this data is 19. So the 50% data range is the 19. That is the practical interpretation. Suppose if your data is even number, suppose this same example I given for 18 readings. So how we will calculate the IQR? Now we need to just divide the data into two half, and from the two half you need to again identify first of middle value, median, as well as the second of middle value. So this IQR value is Q3 is 38 and Q1 is 20. For this example, the IQR value is 18. So now some additional information. So no need to use calculation of this all the things. You can use directly Excel to you find the all these three range, standard deviation and IQR value. Range is the very easy method. You can use maximum function as well as minimum function in Excel. And the standard deviation for sample data, you can use stdev.s function to calculate the standard deviation of the sample, as well as for the population you can use stdev.p function for the population data to find the standard deviation. And for the interquartile range, you can use quartile function. In that you need to select the data, comma 3 indicates Q3, minus again quartile, and select the data, and 1 is indicate the Q1. So hope it's useful formula in Excel if bulk data. I mentioned here. Thanks. Please subscribe.